Hello everyone, welcome back to part 2 of the devlog series about making my first game in Unreal Engine. Today, much like yesterday, is also going to be a little unscripted and also long form, but I have planned about certain topics that I want to talk about and cover for this video. So with that said, let's get right into it. So let me open up Unreal Engine and let's come back to our gameplay. And once I hit play, the topic I'll be covering today is getting the tile under cursor, specifically a shape under the grid system, right? So let me quickly get a couple of summon tiles or summon dices, and now we have 3. I can come back to my dungeon setting, and this is the feature we'll be covering today. So we can see this T tile here, which is proportionally mapped to the grid system as well. So the mesh is being mapped onto the tiles of the grid, and that's what we're covering today. And I think that's quite generalized problem, I should say, because if you have a city building game, you have to place buildings on a grid. You have to project the area or the footprint of the building into the tiles of the grid. So I think this is a worthy topic to talk about for today and kind of explore in a little bit more detail. The first thing we need to get out of the way is obviously the grid system, and depending on how we have made the grid system, you might or might not have a function to convert the world location to a tile in the grid. And if you have watched other people's tutorials, like the popular tutorials on YouTube in regarding Unreal Engine, at least, you might have come across someone named Quevillon, or I'm sorry if I butchered your name, but I think he's a French-Canadian game dev, and I've actually followed his series on the turn-based RPG combat system to actually make the grid system. So there's nothing unique here that which he hasn't already done. So if you want to get the grid system and build it from scratch, I recommend you watch his series of building the grid system, right? So I also will recommend another YouTuber, I forgot their name, but they also made a simple grid system, so to speak, which is focused purely on visuals rather than much more complex functions like pathfinding and stuff like that, which Alex kind of delves a lot deeper into, which I required for this project. So I focused on his tutorial series rather than the other person's. I actually first implemented the other grid, but it did not meet the requirements for this project specifically. But if you're someone who's making a project, maybe like a city builder, maybe that would be a better choice for you. At the end of the day, you need one specific function which is called tile under cursor. So what that does is pretty much take a world location and then convert it into a grid tile. So let me give you an example of what I'm talking about. If I hit play and go back to my dice system and get a couple of summon dices, just like these two, I think we're getting quite lucky today. And you can see if I quickly eject from the game, if I press F8, I can eject, and then this point, this tile here specifically, is called the root tile, which is having the axis or the anchor point pretty much, right, in Blender. So this is going to be the root tile pretty much, and this tile is directly under the cursor. So if I play again, you can see no matter how I rotate it or what tile I choose, this root tile is the one that's being under the tiles cursor, the summon tiles cursor, right? And no matter how I rotate it, it rotates on that axis. And that's pretty important because what we're doing essentially is taking the cursor, doing a line trace, and getting that position and converting that into a tile in the grid. So let me quickly try to find that function. Summon tile, and it should be under tick, so update tile under cursor. So this function here gets the tile index under cursor. So let me open that up, and this is pretty much what we're doing. So in Unreal Engine, you have a neat function to get the location of the hit result under the cursor. So that's what this function is all about. We get the player controller, get the hit result under cursor by channel, and then we get that location, right, and then convert it into a grid location or a tile location pretty much. So this is the whole function, Again, I'm not going to be showing this a lot or explaining this, because you can watch Alex's video on that. I think he does a wonderful job of explaining how everything works in detail. So keep in mind, you might need this function in your game. I think it's a core function. If you are going to make a grid, you might as well have it, right? So that's pretty much all we're doing, is we have a function that converts the world location, any given world location, to a tile location. And that's the same function we're calling for the, or for mapping the tile shape into the grid, right? So if I come back again, come back to my door rise, door rise, door rise, dice roll, yeah, dice roll. Okay, so I haven't gotten lucky now. So we have two summon tiles again. So if I come back again, I can show you my tile, summon tile, dungeon tile. This is pretty much our territory we're gonna spawn, right? Okay, another thing I forgot to mention in my last video is that you can't just place your summon tile just anywhere. So if I click somewhere, it's not placing, and that's because you can only connect them or extend your territory, which means you can place them anywhere adjacent to your existing territory, right? So I can't place it here, I can't place it there. But when you start the game, you have a dice master, and your dice master obviously is your only existing territory, right? So if I come back adjacent to my dice master, now I can place it, right? And if I come back, roll another dice, so I got quite lucky this time, and I can't place it anywhere, but now I can kind of adjacent to my territory, and then now we have a new territory, or expanded our territory, so to speak, right? So how do you snap a shape of any mesh to the grid system, or project them into the tiles of a grid? Well, there are two approaches to this. I think the first approach I came up with was quite complicated and very mathematical in nature, and I'm actually going to go briefly over it. Maybe you guys can try it out, but I would not recommend it at all, right? So my first solution was to use a binary tree data structure with the information of each tile respective to the root. So what I mean by that is, if I hit play and go back to my dice roller and get two dices, as I said, we have one root tile, which is actually the tile under cursor. So if you move the cursor, that root moves with the tile. We'll have a binary structure, tree data structure, which has left and right nodes pointing to the connected tiles, so up and down. If I eject quickly, this is what I mean. So this is going to be the root tile, the left is going to be this tile, right is going to be this tile, and for this, left and right is going to be this and this, this and this, right? But in a real sense, you'll not use left and right, you would use a left, right, and up and bottom, because we're using 2D obviously, right? So it's not going to be one dimensional, it's going to be two dimensional, which will make things even more complicated, and that's not even accounting for rotation. So if I quickly rotate my tile, now we have to restructure the entire binary tree structure. So that'll be quite complicated. It'll be procedural. That's the only advantage of the system, is that it's very procedural. You could have a billion different meshes, right? And then project them effectively into the grid or the tile system, right? And I think that would be the only way you would do something so complicated like that. But even still, I think the disadvantages outweigh the advantages. With that said, I'm actually going to show you my solution, which is pretty simple. You might have noticed when I hit play, a couple of tiles unfolding in the background, right? I forgot to hide them, so I might as well hide them now. These are the blueprints that I made in that contains the skeletal mesh and the animations that I made in Blender. I'm not going to go over Blender in this video because I might do sculpting in the future for my characters, of course, but this is pretty self-explanatory. You take a cube, the size of the grid, the size of the tile size, both are equal, and then you extrude it in either direction with 6 sides. Pretty much a cube unfolding scenario. We have 11 possibilities here, and you just have to copy paste them into Blender. There are graphs out there, you can copy them, you can follow them, or you can just use your brain and figure things out, right? So yeah, just let me get into one of these blueprints and show you what's going on. So this is my skeletal mesh from Blender. We have, don't worry about the materials. It's pretty self-explanatory, that's all I can say. One thing I would recommend is that once you have the mesh imported from Blender, I would recommend you to add normals to the mesh inside Unreal Engine, because sometimes it does something freaky, shading problems and stuff like that. So I would recommend you do that. So let me quickly show you how I did that. Tiles, meshes, and let me take a tile and place it here. So the big T here. And all you have to do is go into modeling mode, and you'll have something called UV unwrap. Yeah, auto UV or unwrap. Do those two and you'll be fine for the most part. Essentially, this is just a dummy for me to judge things in the game, like for prototyping and stuff. So I haven't really put much thought into it. I obviously have to model things better, maybe sculpt some tiles like the one you see in the anime, like with monster flesh and stuff like that. That'll be pretty cool actually. And sculpt them on top of these and then retopo them, put the normal maps. I think that would be pretty cool. That would be one of a good exercises for this development process. So I'm actually going to delete that and come back to a blueprint and actually talk about how we're getting the or projecting the mesh into the tiles or the grid system essentially. So you might have noticed already, I have a couple of static meshes, empty static meshes, that are called trace points. Now I have to rename this obviously, because I'm not going to line trace through each of them, because we don't have to, because they're already positioned in a way that is the center of the grid, right? So this is the center of 100 grid, and this is going to be the center of another 100 grid. This is going to be, what I'm saying is they are spaced equally to fit perfectly within each grid, pretty much snapped to the grid, right? And I did that by simply using the move tool and then snapping it to the 100 size, right? Which is pretty much the size of my tile, right? So you have all these points, and then all you do is the easy part, right? When you project them into the world, for example, a tile, I get summon tiles. Okay, we're getting quite lucky today. And all you have to do is place a mesh on top of the tile cursor. And remember I said something about a root node and a parent axis, or the anchor point pretty much, right? So what's happening now is, if I come back outside, you might not see it because it's hidden in game. That mesh right there is missing, right? We had a blueprint here just a little while ago, and that's because that blueprint is actually hovering right over the tile. It's actually right here, and we can't see it because it's hidden in game. Let me try to find it here. A big T, so you can see it. Look, when I click the dungeon tiles big T, the blueprint actually exists over here. It's hidden in game because we'll just use the points, the trace points. We'll convert their world location into the tile location, and then pretty much do whatever we want, because when we convert that in tile location, we get the tile index back, and then with that index we can do whatever we want, right? So I'm hoping it makes a little bit of sense after I show you the code. It's pretty simple actually. You don't have to do line traces because it's already snapped to grid, and if it is snapped to grid, you don't have to do anything, right? So we come back to this one, come back to highlight. Yeah, and this is going to be right. So highlight dungeon tile, we call that function in the event tick, and then we go get the current dungeon tile, which is obviously going to be the one that is taken from the pool, the dungeon tiles from the world scene. Take it and we hide it, right? And get all the components with the tag of trace point, and then go through each of them and then get their world location. So we convert the world location into a tile index, and then we simply change the tile index state. So here we're changing the state into hovered, obviously, and when we click plus, right, click place button pretty much, then we call the same function again here. Yeah, right here, get world location, and then here we're just setting the style state into selected pretty much. And I would also recommend using enumerators pretty much for checking the states of each tile, because you could have multiple states in each tile, like an array of enumerators. It could be selected and a pathfinding tile at the same time. It could be selected and an enemy tile at the same time, right? So enumerators are pretty good in that essence, because imagine you had to use an array for each tile state, right? So let's say the hover tile, I have to get 6 tiles and put them into an array, and every time I have to change the state, I have to remove them from the array of the selected array or hovered array and then change them into the new array, which is quite complicated, right? So use enumerators as much as you can. And this is also from Alex's video, so shout out to him for all this concise logic, right? So I guess that's pretty much it for the highlight tile and the dungeon tile. I'm going to give you a brief summary, right? So what we're essentially doing to map a shape, any shape you want, into a tile system of the grid is you pretty much get equally spaced apart points in the mesh, right, like I showed you in the blueprint, and then you project their world location into the tile. So the important part here is that you have an implementation for a function that converts world location into a tile from the grid system itself, right? So you could imagine this being applicable again for the same scenario in a city builder, right? You might want to convert the footprint of a building into the tile system from a grid, right? How would you do that? Well, you take the footprint and then you equally space apart certain points, and then you trace those points into the tile system, or convert pretty much, not trace. I think that's a little bit misleading. You don't trace anything, right? You know, for all I care, you could pretty much clamp it to the floor, right? Take the Z value and just clamp it to the floor Z value. It would work. But just to be sure that it's dynamic, you would take that point, convert that into a tile location, and you could do whatever with that tile, right? So I want to cover on one more thing before I end this video, is that if I come back to my blueprint, you could argue that manually setting these points could get quite cumbersome depending on the footprint of your mesh, right? So it makes sense, right? So here we only have 6 points that we have to take care of, because a cube only has 6 sides. But let's say your house footprint is actually equal to 20 areas or 20 tiles of the grid. You could obviously manually go and place 20 points like I did here. I actually went and manually pasted each of them. Or you could actually do something clever and dynamically or procedurally generate these points. So one way to do that, I think, would be to start at the root node. So why root node? Because when you get the get location, skeletal mesh, get location, get world location, it's going to be returned to this node. So if I click the skeletal mesh, this is the axis, right? So this is the root node. So you have to make sure it's snapped to the grid, at least that much, in the 3D program you're working on, right? I explicitly snapped these to grid in the 3D program. So once you have that, you could pretty much increment a line trace, if you get what I mean, right? So let me try to sketch this out. Let's see if OBS has a drawing tool. I don't think it does. Okay, OBS doesn't have a drawing tool, but I'll try to put something on the screen right now as I talk. So what you could do is first take the point or the world position of the mesh you're in, the footprint you want to cover, and then do a line trace from there, and then add a trace point to that location. So that will become trace point number 1, and then you increment the next location in either axis, negative and positive included. So we're going in 2 dimensions. So in this case, let's say we're going in the y-axis by plus 100, right? So from the world location, right? So y-axis plus 100 in the world location is going to be this guy here, and then we draw a line trace from the top infinitely above, right? And if the line trace hits something and that is the mesh you're in, then we can add a point there, we can spawn a trace point there, and then we could do the same, right? So we do 4 times, we go x this time, plus 100 points the tile size, and draw a line trace on the top. Does it hit anything? This time it doesn't. Then we go again y plus 100, draw a line trace on the top, 100 increments, doesn't hit anything. Then we go x again, positive direction, doesn't hit anything. So then we come back up and then come back to the other side, 100 increments, it hits something, so spawn a point there, and then do that respectively for all these other points. This is obviously going to be a little bit more consuming in the CPU part, because we are going to do that in the construction script actually. So maybe even before the game begins, you might have to hide it in the loading screen and stuff like that. But I think the advantages for that only shows when you have large number of meshes that you want to cover, right? Even if you had a footprint that you want to cover that's very large in terms of area, you could still manually do that and get away with it because you just have 2-3 houses to cover, right? But let's say you have a city building game that has 300-400 unique houses with unique footprints, so base meshes, then you might consider procedurally generating trace points and then projecting them to the tiles in the grid, right? So that's something to keep in mind. I think the only time you get the advantages is with the number of possibilities. If you have very high number of possibilities, then doing it procedurally will make a lot more sense. Like the dice I mentioned earlier yesterday, I said you could procedurally or manually go and make dices with every possibility, right? So 6 to the power 6 is a lot of possibilities. I calculated it and it was like about 46,000 possibilities. So you manually making 46,000 cubes is a very time consuming process. So in that instance, it's much better to give the computer the job to take a little bit of CPU power, but in the end get every possibility covered, right? So I think that's a similar situation here. So if you have just 10 houses, it's better to manually place trace points. But if you have 10,000 houses, I think it's better to procedurally do it in exchange for a little bit of compute power. So I guess that's pretty much it for today's video. If you guys found the video enjoyable or informative, make sure to leave a like and consider subscribing. I'm also on Patreon, so if you guys want to support the development of the game and get exclusive behind the scene access, make sure to support me on Patreon. I think I said that twice, but yeah, thank you guys for watching, and I will see you guys in the next devlog.